it's time to update our catalog microservice so that it starts publishing messages anytime an item is created, updated, or deleted. So I'll start by opening a terminal so that we can bring in a couple of NuGet packages that we're going to need. So here I am in the play.catalog directory. I'll switch to src and to play.catalog.service, not the contract, but the service one. And here I'll add .NET add package masstransit.ASP.NET Core. Okay, so this one brings in a bunch of functions that we're going to use in order to interact with the mass transit libraries. And the next package is going to be masstransit.RabbitMQ. So this one introduces a couple of additional APIs so that we can explicitly use the RabbitMQ service bus. Okay, so with those added, let me close this terminal. And I'll go to Play Catalog Service and into our items controller. And perhaps I'll close the navigation pane for now. And here we're going to do a few things. First, let's get rid of this temporal code that we added in previous lessons to simulate temporal failures. So we don't need really any of this anymore. Remove that, and I'll also remove this request counter that we had added. Now, the first thing that we're going to need here in order to be able to publish messages is what we call a publish endpoint. So this is the class that allows us to really communicate that we want to send messages to some location. So I'm going to declare a variable of type iPublish endpoint. Let's call it just publish endpoint. And for this, we're going to need to import the mass transit namespace. And then we're going to receive this variable as via dependency injection into the constructor. And then we will grab that instance into our publish endpoint variable. Now we can go to each of our controller actions, operations, where we want to publish a message and start sending those messages. So I'm scrolling down into our post async method. Now what we're going to do is that just after creating the item in our database, we're going to publish a message announcing that the item has been created. So I'll do await publish endpoint dot publish, and here's where we're going to use our new set of contracts, and we will start with our catalog item created contract. And let's see, control dot. We need to import the play catalog contract namespace, and here we have to provide, of course, the item.id, item.name, and item.description. And that's really all you have to do to publish a message. And I'll copy this line because now it's time to go to our put async method and do something very similar. So just after updating the item into the database over here, let's add and paste that line. But in this case, the method is going to be catalog item updated. And we will use the existing item variable that we have here. We'll use the ID, the name, and the description. I'll copy this once again. And let's go to our delete async method. And again, just after removing the item, we will go ahead and publish a message saying that we have a catalog item deleted, which is going to be just the ID that we received from the parameter. So yeah, so that's all you have to do. And so now any consumer of these messages that is listening to the queue, to the right queue, will be notified that an item has been created, updated, or deleted. Now what we have to do is to do the proper registration in Startup to configure and to register the classes that we need for mass transit and for RabbitMQ. So I'll open my Explorer here. And I'll go first to app-settings.json. Here, just like we did with MongoDB, we need to add a little section for our RabbitMQ settings. So I'll open a section here. Let's name it RabbitMQ settings. Open a section here. And here, the only thing that we're going to declare at this point is the host. So where is this RabbitMQ server living? And in our case, since it's all local machine, it's just going to be localhost. You could specify more details like username, password, and a bunch of other settings. But for now, for local purposes, we will just accept the defaults and we will go with localhost. Save that. Now, just like we did with the other settings classes, we need to introduce a class that represents the RabbitMQ settings so that we can use that in startup. So I'll create a new settings directory here now. And of course, we will move this later into our shared common library. But for now, let's just do it here and we will do that refactoring later on. So I'll add a new file into the settings directory. Let's call it RabbitMQ settings.cs. Let's add a namespace, play that catalog, that service, that settings, and then let's declare our class, public class, RabbitMQ settings. And as we know, the only thing that we need here is the host. So I'll declare our string host. And as with any other settings class, we will use this as an init as opposed to set, because nobody should be setting these properties after they have been deserialized from the configuration file. So save that. And now it's time to go to startup to register what the services that we're going to need. So I'll go to startup. And again, I'll collapse this navigation pane. So here in startup, I'll locate our configure services method right here. And then we will add the mass transit classes just before the controllers. Let's do it here. So we're going to say services that add mass transit. And we will receive a variable here that we're going to be using to configure things. I'll open a section here. Close this. Let's see if we're missing something. Yeah, so we need to import the mass transit namespace. And then we will use this X variable here, that we call the configurator, to specify the type of transport that we want to use. In our case, that transport is going to be RabbitMQ. So we have to say X dot using RabbitMQ. And then we need to specify a function to configure the RabbitMQ. So in this function, we're going to declare two parameters, which are going to be the context and the configurator. And then let's give this function a body. Let's close that, save. And the first thing we're going to do here is to get an instance of those RabbitMQ settings so that we can figure out what's the host that we're going to use. So we will just say RabbitMQ settings is going to be configuration, get section, and then the section that it should have the name of RabbitMQ settings. RabbitMQ settings class. And let's see if we're missing something. Yeah, we need to import the play catalog service settings namespace. And when we have that, we can say, okay, so now get it as a RabbitMQ settings type. Okay, so we have the settings. And now what we can do is use the configurator to set the host where our RabbitMQ instance lives. And that's going to be in RabbitMQ settings.host. And now we'll add one more line. This is not necessary, but I think it's very handy. And this line is going to help us define or modify a little bit how the queues are created in RabbitMQ. So I'll do configurator.configure endpoints. And here we're going to receive the context and a formatter. And what we're going to use is the kebab case endpoint name formatter. See if we're missing something. Yeah, we need mass transit definition. And in this formatter, we're going to define first the prefix that we're going to be using for our queues, and that's going to be service settings dot service name. And then we will not need to include the full namespace of our classes in those queues. So we'll just say false here. And lastly, we'll add one more line just after this one to start the mass transit the hosted service. So we'll say services.add mass transit hosted service. This is the service that actually starts the RabbitMQ bus so that messages can be published to the different exchanges and queues in RabbitMQ. So I'll save that. And for one last change, I'll go to our Explorer, and I'll go to app settings.development.json. And this is something that I like to do more for demonstration purposes than for anything else. But this is changing the default login level from information to debug. So I found that this is going to be very handy for us to understand what's going on behind the scenes when messages start flowing between services. So we'll do that over here. And at this point, the catalog microservice is ready to publish messages to RabbitMQ, but we don't have a RabbitMQ instance available just yet. In the next lesson, we will expand our Docker Compose file to also stand up a RabbitMQ Docker container that our catalog service can communicate with. It's time to stand up our RabbitMQ message broker. And of course, we'll use Docker for that. So here I am in Visual Studio Code. And what I'll do is I'll open our play.infra directory, so play.infra, and then I'll do code.-r. And here I'll just go ahead and close this, close that, and I'll open our Docker Compose YAML file. And perhaps I'll collapse this. So the first thing that I'll do is I'll go ahead and remove this comment that we had at the top. And now we can go ahead and start declaring our RabbitMQ service. So just like we did with Mongo, we'll come here and we will declare a service for RabbitMQ. Let's name it RabbitMQ. And then, as usual, the first thing that we want to declare here is the image that we're going to use. That image is in this case is going to be the standard RabbitMQ image. That includes also a portal to manage the RabbitMQ infrastructure. So that will be RabbitMQ management. Then we will mention the container name, the name that we're going to give to this container, and it's just going to be RabbitMQ. Then we'll go for the ports section. We're going to open two ports. One port for our services to communicate with RabbitMQ, and then another port for us to be able to navigate to the RabbitMQ portal. So the first port is going to be 5672, maps to the same one internally, and the other port is going to be 15672, which maps to the same port internally too. So the first one is going to be used by the services to publish messages to, or to consume messages from RabbitMQ, and the second one is going to be used to be able to go to the portal, to the RabbitMQ portal. Then we're going to go to the volume section, and we're going to declare a volume also for RabbitMQ, which is important because we don't want to be missing those messages if the RabbitMQ container goes down. So I'll just declare RabbitMQ data. And now we have to map that volume into some location in our RabbitMQ image or container. So I'll declare volumes. I will copy RabbitMQ data. And the location that you want to map inside RabbitMQ is going to be var lib RabbitMQ. And one more thing that we have to specify here, which is pretty important, is the host name. So host name, and we will give it the value of RabbitMQ. So this one here is pretty important because this is associated to how RabbitMQ stores data internally. And if you don't specify it, then it gets a random value. And then each time we restart the container, RabbitMQ would store data in a different place, which is not going to help us really a lot. So keep in mind, you always want to specify here. It doesn't matter what value you use here, but you have to specify some value. Okay, so with that done, I'll do Ctrl S to save this file. And then I'll open the terminal. And it's time to start this container via docker compose up-d. Hit enter. And since this is the first time that I'm pulling in the RabbitMQ image, so you have to download it to my machine. Like I said, next time it will be faster. So yeah, now we have we have RabbitMQ up and running over here. And with that, we can start trying this out. So I'll go back to our catalog project. And here we're going to start the catalog web server, but we'll do it via .NET Run so that we can take a closer look at what's happening behind the scenes. So I have opened the terminal, Ctrl-J, then I'll do src, and then I'll do pay.catalog.service. And then let's just do .NET Run here. I'm going to collapse this also. And so a couple of things to notice here is that, so yeah, Mass Transit is doing its job. It's starting the bus, and then it has connected to RabbitMQ in port 5672 using the protocol AMQP. So here's where you can see the actual address of RabbitMQ in the Docker container. Like I said, this is the one port to connect to the queues. And so things are looking ready on this side. So now we'll go to Postman. And what I'll do is I'll go ahead and I will create an item in our catalog. So I'll go to our catalog API and I'll open the post one. And here I'll create some new item. Let's say this time we're going to create an antidote. So antidote, cures poison, and then price is going to be 7. And I'll hit send. So that item got created in the database. But now let's see what else happened. So if we see now here, yeah, the item got created, but also an exchange was created in RabbitMQ. So Mass Transit created this exchange in RabbitMQ for us. That's one of the nice things about Mass Transit, so we don't have to create it manually. And it got the name play catalog contracts, and then the name will be catalog item created. So an exchange will be created for each of the messages that we publish from catalog. And you can see that after creating the exchange, it also sent the message to that exchange. The message was sent over there. And so if you want to see how this looks like in RabbitMQ, actually, we can go ahead and check out the RabbitMQ portal. So let's open that portal now. Here we are in the browser. Let's go to localhost 15672 is the place. And here we're going to use just the default username and password for RabbitMQ. So that's going to be guest, and it's exactly the same password, just guest. Login. And in this UI, you can see a bunch of things, but really the one thing that I wanted to show you now is the exchanges. And as you can see, there is a exchange created here, catalog item created, and is of type fan out, meaning that anybody listening to this exchange will be able to get the messages. And then catalog item created, I'll go in there, and then there's not much to see here because the exchange just takes messages from one place to the other. It's not going to store the messages. And then as you can see, the exchange right here in binding section, it is not connected to any, it doesn't have any bindings just yet. And that's because we don't have a consumer of these messages yet, which is going to be inventory. And but it's not there yet, so the queue has not been created. And so there's no destination for these messages just yet. And so at this point, we are able to publish messages from our catalog service anytime our items database is updated. So in the next lesson, we will generalize some of the code that we have added here into our common library in preparation for having inventory start consuming the published messages. Let's move the code that configures Mass Transit and RabbitMQ into our common library so that things get easier and cleaner for catalog and any future microservices. So here I am back in our catalog project, and I'll start by going to our settings folder, and I will copy our RabbitMQ settings file, copy that, and then I'll switch to our common project, our common library. I'll open our settings folder and I'll paste the copied class. And I'll grab the namespace from some other of our settings classes. I'll just fix that namespace here. Save. And now before adding the Mass Transit classes, let's bring in the NuGet packages that we're going to need over here. So I'll do Ctrl-J. Let's go into source, play.common, and let's add the same NuGet packages that we already added into catalog. So .NET add package mass transit.ASP.NET Core, and then let's do mass transit.RabbitMQ. All right, so with that done, let's go ahead and create a new folder. Let's call it mass transit. And perhaps let's close this terminal for now. And just like we did with MongoDB, let's add an extensions file here, where we're going to add our handy extension method. So let's first declare a namespace. play.common.mass transit. And now let's create our class. This should be a static class. And now we'll bring in our extension method. So this is going to be public static iService collection add mass transit with RabbitMQ. So that way we can do all the registration for mass transit and RabbitMQ in one location. Let's add the missing namespace and let's extend iService collection services. And here is where we're going to bring that code from the catalog service. I'm going back to catalog into the startup class, scrolling down. I'll copy these lines, copy that into common, and I'll paste them over here. And now let's start fixing all these missing namespaces. So at mass transit, we need to import using mass transit. And then for RabbitMQ settings, we'll need to import play.common.settings. KVAT case endpoint name for matter, we'll need mass transit.definition. Okay, and just like before, we also will need an actual instance of the configuration class and an instance of our service settings class. Now these are very similar to what we did in MongoDB. So let's see if we can get something from there. So MongoDB extensions, let's see, let's grab these two lines. Let's close this and into this spot there. And let me collapse this navigation pane now. So here we also need an import for iConfiguration. Let's grab that, extensions configuration. And you can notice that there's no service provider variable available here. However, we do have a service provider, and that is this context class that's over here. This iBus registration context is actually a service provider. So we'll use that as the class that can give us an instance of iConfiguration. We can also fix this other configuration member here. And let's also rename this X variable here to something more meaningful. Let's name it configure. And since we are here, one more thing that we can do is to perform the consumers registration. The consumers are the classes that are in charge of consuming messages from the RabbitMQ message queues. We have not created these classes just yet for catalog because catalog is not consuming but just publishing messages, but we will create these classes in inventory. So since inventory will be using this method, we might as well just add that registration over here. So I'll open a couple of lines here. And what I'll do is I'll just say configure.add consumers. And there's a few ways to register consumers. The way we're going to do it is that we're going to specify the assembly that should have all the consumers already defined. And that's going to be the entry assembly for whichever microservice is invoking this class. So to get that, we're going to say assembly, and we need another import here using system reflection that get entry assembly, and that should do it. Okay, so any consumer classes that are in that assembly will be registered by this method. And finally, let's go ahead and return our services instance to complete this method. Okay, so with that, let's make sure everything is built in. So I'll do Ctrl+Shift+B. And yep, everything builds just fine. And now let's go ahead and package all these new changes into a new version of our NuGet package. So let's go back into our PowerShell terminal and perhaps I'll clean this. And just like we did before, we're going to do .NET Pack. But this time we're going to specify a version. Last time we didn't do it, and that generated version 100 for package. This time we need to increase the version so that our consumers can actually notice that there's something new available in the package. So to specify a version, what you can do is use the -p parameter, and then you specify package version, and then you specify the version. So I'll say 101. And then just like before, we'll specify an output directory. It's going to be the same location as before. Packages, enter. And we got a new NuGet package created right there. So now let's go back to our catalog project and start taking advantage of this package. And first thing I'll do is I'll delete our settings directory once again. We don't need it. Get rid of it. Then I'll go to our project file. And since we're bringing in this NuGet package that has all the mass transit stuff, we should not need these two references. So I'm going to get rid of them. Save. And now what I'll do is I'll just go to our play.common dependency, and I'm going to bump the version number here. This is 100, bumping it to 101. I'll hit save. This pop-up dialog shows up asking us to resolve the updated dependencies. So I'll click on restore. And that's going to bring in the updated package into catalog. So I'll close this and I'll close that. And now it's time to update our startup class to take advantage of the new package. First, let's get rid of this unneeded import at the top. And now what we can do is just, since it's Fluent, let's expand on top of our add Mongo repository. So let's just do add mass transit with RabbitMQ. We may be missing a namespace, so we need to import play.common.masstransit, and then that becomes the one line that we have to run to execute all this stuff that we were doing before. So I'll get rid of all these lines, save, and that should be good enough. I'll do a Ctrl+Shift+V to make sure that things are compiling. Yep, it's looking good. So let's go back, let's open a new terminal here. And let's verify that things keep working properly. So I'll go to SRC. Oops, not into contracts. We want to go into service. And then I'll do .NET run. Yep. So yeah, we are connected. We have connected to RabbitMQ. So it's time to do something about messaging. So let's go back to Postman. And last time we had created this antidote item. And so instead of creating a new one, why not let's try an update operation. So a put. So I'm going to just copy this. And then let's go into put. And then in the body, we're going to just paste this. So it's the same antidote, curse poison, but let's say that the price is now 9. And then let's bring the ID. Hopefully it's the same ID that we used before. So I'll copy this ID into the URL for the put operation, and then I'll hit send. So we got 204, so it was a success. And now let's go back to VS Code. And yeah, just like before, the exchange was declared and the message was sent to the exchange, as you can see. But this time we should have a new exchange. So let's go back to RabbitMQ briefly. And here, let's go now to exchanges. And as you can see, there's a new exchange here, catalog item updated. So things are working properly. And one last thing that we have to do here is to actually publish the catalog contracts as a NuGet package so that inventory can use it in the next lesson. So let's go ahead and go back to catalog. And here I am. I'm going to do Ctrl+C in my terminal so that the host stops. And then I'll switch to our play.catalog.contracts directory. And here I'll do what we did before. So .NET pack, and then output directory, packages. So that should go ahead and produce our contracts package. Hit enter, and there it is. So now we have a contracts package that inventory service will be able to use to consume the messages. In the next lesson, we will update our inventory service so that it can consume the messages published by catalog. The whole point of moving inventory to using asynchronous communication is to have its own database of catalog items that it can use without ever having to get in touch with the catalog service API. Therefore, let's start by defining the entity that represents catalog items in the inventory microservice. So here I am back in our play.inventory microservice, and I'll open our entities directory. Now this new entity that we're going to create has some similarities with inventory items, so I'm actually going to start by getting a copy of inventory item. So I'll just copy this and I'll paste it right there. And let's rename this into catalog item. Catalog item, and we rename this as catalog item, which also implements iEntity. But in this case, it's not going to have most of these properties, but it's only going to reuse the ID. Now, as you remember, the catalog item has a bunch of properties in the catalog service, but here we will only introduce the properties that make sense for inventory. So in this case, this is going to be, we'll start with the name, and then we will also need description. Okay, so keep in mind that as you're bringing in these entities from other microservices, you don't have to have everything that these entities have in the other service. It's only the version that the new microservice needs. In this case, just ID, name, and description. With that done, let's go ahead and start bringing in the NuGet packages that we need for this. So I'll go to play.inventory.service csproc, and then I'll open my terminal. So let's go to src inventory service, play inventory service, and let's get a reference to our new catalog contracts NuGet package. So .NET add package play.catalog.contracts. Remember, this has all the contracts that we can use to consume messages from catalog. Okay, with that done, let me close this, and now you can see that we have play catalog contracts here. But we also need to bump the version of play.com because remember we added some new new classes in there. So I'll bump from version 1.0.0 to version 1.0.1. I'll save that. Let's go ahead and restore the new NuGet package. And now we can close this. Close these files. Now it is time to define the consumers. And like I said before, the consumers are the classes in charge of consuming the messages that have been published by any other microservice. So to define the consumers, let's go ahead and create a new folder. Let's call it consumers. And we have to create one consumer for each of the different operations that happen in catalog. So that's for creation, update, and delete of catalog items. So I'll go ahead and create a new file. Let's name this one catalog item created consumer. I'll copy the name. Let's give it a namespace. Service consumers. Okay, so this is our catalog item created consumer. And the first thing that you have to do about this consumers class is to make sure that they are actually consumers. And to do that, you have to implement the iConsumer interface, which is part of mass transit. And I'll do control dot, so using mass transit. And here you also have to specify what is the type of message that this consumer is going to handle. And that type of message is actually coming from the contracts that we're bringing in from catalog. So in this case, it's going to be catalog item created. See if we're missing something, using play.catalog.contracts. So then let's go ahead and implement this interface. So I'll do control dot here, implement interface. And as you can see, we just have to implement one method which is the consume method. So which is where we're going to actually perform the action of consuming the message. And so what we want to do when we consume the message is actually store it in our local catalog items database. So to do that, let's first introduce a repository that we can use for that. So I'll declare read-only iRepository of type catalog item. Okay, so this is the new entity we just introduced for catalog items in inventory. All right, Let's see if we're missing something. Play that common for iRepository. And play that inventory service entities. And now we need to inject this repository in the constructor of this class. So let's define a constructor. So public catalog item created consumer. And so here's where the repository comes in. Okay, so let's say this repository equals repository. Let's now go ahead and implement the consume method for this class. So I'll get rid of this, and let's first get a copy of the message. So the message that we're receiving is available in the context variable as the message property. So let's grab that copy there. And then what we want to do as we consume this message is probably first make sure that we have not consumed this already, right? We may have already consumed a message of the creation of an item with the ID that we're going to get in this message. And if we did, we already would have that into the database. So let's make sure that we don't have it. And if we do have it, let's just return. There's nothing else to do. But if we don't have it, we'll go ahead and create it. So let's see. Item is await repository get async, and that's going to be in message dot item ID. Let's also make sure that this method is async. And then if item is not null, then we will go ahead and return. Okay, because in this case, it happens to be that we already created this item in our local database, so why would we create it again? If not, we will say new catalog item, and then we'll say all these message.item ID, name is message.name, and description is message.description. Finally, we'll go ahead and do repository.createAsync of this item. Okay, so that's all you have to do to consume a message that represents a new item that has been created in the catalog. Like I said, we just verify if the item is already here, because it could happen in the cases where for some reason the publisher publishes the same message twice. And so we don't want to be having errors here because we already have the item in our catalog items database. So if we don't have it, we will go ahead and define it and create it into our local database. Let's go ahead and do something similar for our updates. So when a catalog item has been updated. So I'll get a copy of the consumer, and let's just rename it into catalog item updated consumer. Okay, so I'll do this, and then the message is catalog item updated. Okay, so let's fix a couple of things. Constructor there. Okay, so we are consuming now catalog item updated, and here the logic is going to be a little bit different. So but for an update, it could be that we already have this inventory item in our local database. So in which case we'll need to go ahead and just update the properties. Or it could be that this is the first time that we receive this the message for this item, in which case we'll go ahead and create it. So now in the case that, so first, just as before, we can go ahead and get the item, but if the item is null, so we'll change this, if item equals null, then we will go ahead and define these lines that we had over here. There. So if the item is null, we don't have it in the database, so let's go ahead and create it. Otherwise, let's just update the properties that make sense. In this case, it's going to be item.name equals message.name, and item.description equals message.description. And in this case, let's go ahead and call await repository dot update async item. Okay, so quick recap, for an update operation, we go ahead, find the item. If we cannot find it, we will go ahead and create it into the database. And if we find it, we update name and description and update it into the database. Now let's go ahead and implement our third consumer, which is going to be for deleted items. So again, I'll get a copy of this last consumer, paste here, And let's rename it into catalog item deleted consumer. I'll copy this name. So I'll update the name of the class, the constructor, and then let's make sure we also update the message that we're handling here. This is catalog item deleted. Here and there. And in this case, things are even easier. And so we will go ahead, we'll try to find the item. And if we cannot find it, it means that for some reason it does not exist in our local database. So there's really not much more to do in our case. So we will go ahead and just return. We don't have it, just go ahead and return. And if we have the item, then we can go ahead and say await repository remove async message.item ID. Okay, so with that, we have our 3 consumers defined. And now it's time to perform the proper registration in Startup. And before we can do that, let me go to app settings.json, and we need to declare those RabbitMQ settings so that we know how to communicate to RabbitMQ. So I'll actually go back to catalog, our catalog service over here, and I'll just grab those 3 lines for RabbitMQ settings from app settings.json, and then back to inventory, we will add that over here. Same thing, we're talking to localhost for RabbitMQ. Now let's go to Startup. Okay, perhaps I'll collapse this for a moment. So let's do a few things here. So as you see, we still have this logic to use the catalog client to talk to the catalog service. We will not be using this anymore, but let's keep this logic around in case you want to reference it later. But what we're going to do is we're just going to refactor it into another method so we don't have to have all this stuff hanging around here. So I just selected all this logic to use the, the retries and the configuration of the client. I'll do control dot and I'll say extract method. So we'll name this method add catalog client. And I'll take this method and just send it to the end of the file so that we don't have to see it frequently. And now a couple of things that we have to do here for our new catalog items repository and mass transit. So first, we need to introduce a new repository here for the catalog items. So I'll say add Mongo repository, catalog of catalog item. And then we need to give a new name for this new collection of items. In this case, it's going to be catalog items. Okay, so keep in mind that both of these are going to live in the same database, the same inventory database, but it's 2 collections, one collection for inventory items and one collection for catalog items. And then we also need to add the mass transit registration. So I'll say add mass transit with RabbitMQ. Let's add a missing namespace. And that's pretty much it on startup. Then let's go back to our Explorer. One more thing that I'll do is just like we did in catalog, let's flip the default log level so that we can see also what's going on regarding all these message exchanges. So I'll change this to debug. And with that, our inventory service is ready to start consuming messages. But one more thing that I'd like to do is to actually clean up our databases. And I'll like to do this because at this point, we do have some data, both in inventory and in catalog side, but that data has never been synchronized at all. So it will be better to just start clean in a situation where both sides are actually synchronized from the start. So I'll go back to MongoDB, the MongoDB extension. I'll expand this. And as you can see, we do have the catalog and inventory databases. So to clean them up, I'll just right click and say drop database. I'll drop catalog. And then I'll drop inventory. You may choose to not delete them, but that could cause issues as you start moving forward. So it's better to just start clean in this case. At this point, I'll start our microservices. So I'll do Ctrl-J to open the terminal. I'll go to my terminal. And perhaps I'll do clean. And just so that we can see things better, what I'll do is I'll collapse this and I'll bring in yet another terminal with the split terminal button here so that we can see services in both sides. So perhaps what I'll do is I'll switch to a catalog on the left side. So I'll go to play that catalog. and then pay catalog service. And on the right side, I'll stay in inventory. So I'll do play inventory service. Okay, so let's clean both sides. And now we can start both services. I'll do .NET run both sides. And now notice in the right side that a few new things are happening. And perhaps I'll move this around a little bit. And yeah, it may be a bit hard to see, but exchanges has been declared for the consumers that we declared here. You can see we have exchanges for a catalog item created, updated, and deleted. And if we scroll down a little bit, let's see. These exchanges are now connected to the queues. So you can see that this exchange is now connected to our new inventory catalog item updated queue, same for created and deleted. And the consumers are reporting that they are okay. So they're ready to start consuming messages. Okay, so let's move this over here. So now let's see this in action. So let's go to Postman. And what I'll do is I'll start by creating a brand new item. So I'll go to our post item API in play catalog service, body, and let's define our classic potion example again. So we'll say potion, stores a small amount of HP, and the price is going to be 5. I'll go ahead and hit send. The item has been created, and then let's go back to our terminals and see what happened. So as you can see on the left side, the exchange was declared, catalog item created, and the message was sent, right? So catalog item created was sent. And then on the right side, we can see that now we actually received the message, and that was handled by the catalog item created consumer. So if things went correctly, we should now have a copy of the catalog item in our local catalog items collection in the inventory side, inventory database. So let's go to MongoDB. And let's see what we have. So I'll expand this. So we have the catalog database with this item created here. And then we'll expand inventory. And then you can see that we do have now our catalog items collection with that item created over here. So the item has been replicated from catalog into inventory. We can now take a look also the activity that happened in RabbitMQ. So let me go to the RabbitMQ portal over here, and let's take a look at exchanges. So see that we now have the 3 exchanges for catalog item created, deleted, and updated from the catalog side, and then also the exchanges from the inventory side, created, deleted, and updated. And then if we go to queues, you can see that now we have the 3 queues for the 3 types of events. And if we go to catalog item created, we could see here any activity that goes across this queue. Now the item has been already consumed, so there's not much to see here. But let's see what happens in a case where, let's say that our catalog service is not running, right? So actually our inventory service is not running. So our catalog service publishes some message, but inventory is not running. Now that the queue is up and running, things are going to work in a bit of a different way. So let's go back to inventory, and I'm going to stop the terminal on the right side. Just going to do Ctrl+C. Inventory is stopped now. And let's go back to Postman and create yet another item. So I'll create an antidote, which cures poison, and price is going to be 7. So I'll go ahead and post this. And then if we go back to RabbitMQ, let's see, catalog item created, you can see that now there is one item in the queue as reflected by this. As you can see, it's one item which is waiting to be consumed by somebody. So here is where the nice thing about asynchronous communication starts happening. So there's no need for catalog to be up and running all the time. Inventory can nicely just keep publishing these updates to their items, and then whenever inventory comes back, it should be able to consume the message. And in fact, let's go back to our terminals over here. You can see that the catalog item was created on the left side. And now let's go ahead and start a terminal on the right side Let me collapse this once again. Okay, so on the right side, I'm going to do .NET Run again. And then you can see that right away, inventory is able to consume the new message. So the databases should be in sync again. We can see that there's no more messages here waiting. The message was consumed. And our databases should be once again in sync. Let me refresh this. So yeah, we have 2 documents here and we have 2 documents over there. So things are in sync. So our inventories microservice now have a nice way to stay in sync with any updates to the items managed by the catalog microservice. In the next lesson, we will update inventory so that it starts taking advantage of this new capability anytime it needs to present data that is partially coming from catalog. Now that our inventory microservice has its own copy of the catalog items, it no longer needs to query the catalog microservice to gather additional information about the items of inventory. So let's update our inventory controller to take advantage of its new catalog items collection. So here we're back in our inventory project, and I'll go ahead and open our controllers folder and I'll go to items controller. Let's collapse the navigation pane to get more space. And let me scroll down a little bit. And the first thing that we'll do is to get rid of our catalog client, because we will no longer need to invoke catalog client, the catalog service anymore. Instead of that, we're going to declare another variable here, which is going to be just another iRepository. But in this case, it's going to be of catalog item. So this is going to be our catalog items repository. And since we're introducing this new repository, let's also rename the previous one so that it better resembles its purpose. So this is going to be our inventory items repository. Let's also rename this the variables in constructor. So this items repository becomes inventory items repository. And then it's time to inject also our new catalog items repository as opposed to the catalog client. Here we will capture that. So with that, let's go down into our getAsync method. And here's what we're going to do. The first thing is that we definitely don't need to call catalog client anymore. So we're going to get rid of this. We still need to get the list of all the inventory item entities that represent the items in the user's inventory. So this stays. But after that, what we want to get is from our local catalog items collection, we want to get all the corresponding catalog items that, the ones that correspond to the inventory items on inventory, to the items on inventory. So to get that, let's first get all the list of all the catalog item IDs that are involved in the inventory items collection that we have here. So to do that, let's do this. So item IDs equals inventory item entities select. Let's do a little projection here where item dot catalog item ID. Those gives us the list of all the catalog items that we have in inventory, the IDs specifically. And with that, we can go ahead and get the actual catalog items. So let's do catalog item entities is await catalog items repository, get all async where item. And here we're going to say is that we want to get all the items that are in the item IDs collection. So I'm going to say item IDs contains item.id. So now here we have all the catalog items that match the items that we have in inventory for the current user. Having that, we can go ahead and update this little function here so that it take advantages of this new items collection. So now say catalog item entities is going to go here. So now we can go ahead and say, okay, so as we go through all the inventory items, first we're going to look at the catalog item entities and we're going to find the catalog item whose ID matches the ID of the catalog item ID of the inventory that we're looking at. So that's the catalog item. And then we'll keep moving forward as usual. And we say, okay, so now that we found the inventory item and now that we have the catalog item, let's go ahead and turn it into a DTO, adding the catalog item name and the catalog item description. Okay, So I don't think we need to make more changes to post async. So we should be ready to start using this. So I'll save this. I'll go back to catalog. I'll just going to hit F5 to start the service. And I'll go back to inventory and I'll do the same, F5 to start the service. And now let's go ahead and go back to Postman and let's grant one item to our user. So the first thing that we'll do is actually get the list of current items in our catalog to know what to grant. So I'll just open our get operation in the catalog service and I'll hit send. Here we are. We have currently a potion and an antidote. So let's say we want to do the potion. So I'll copy the ID of the potion. And now let's go to the inventory collection. Let's expand this and I'll go to our post operation where we can assign one item to a user. So I'll go to body. I'll paste the catalog item ID that we just copied over here. So this is the item to assign. And then just like before, we need a user ID. So just as we did before, let's use the Postman function, GUID, to generate a random user ID. And finally, let's get some quantity. Let's say we're going to assign one potion to this user. Okay, and so with that, I'll go ahead and post that, send, and it's done. And if it worked, now our user should have one potion, right? So I'll go ahead and first we need to figure out what's the ID of the user that was generated. And we can do that from the console. So I'll click on the console and I'll go down to our post operation, request body, and it's right here. This is the user ID that was generated. I'll copy that, close console, and then we can go to our get operation to get all the users in the, all the items in the user's inventory. And so we'll get the items for this user. I'll hit send. And as you can see, now we can see that this user has a potion, has one potion, but more interestingly, it is able to show the name and the description of the potion from the local catalog items collection. So it no longer needed to go ahead and talk to the catalog microservice to retrieve the additional information. So things are much more resilient and faster now because we don't need to go out and ask for this additional info. Now, what would happen if we go ahead and update the description of this catalog item in the catalog microservice? How would that look like here? Let's try that out. So first I'll go back to our get items results, and I'll copy a few details about the potion. I'll just copy that, and then I'll go to the catalog collection and I'll go to the put operation. Here's where we can make updates to our item. So I'll just come here, paste that, fix indentation, and let's say that instead of having this description, it just says restores some HP. That's going to be the new description. Also, the ID of this item is this one here. So let me grab it, go back to put, I'll paste that here. And so let's go ahead and update this item in the catalog microservice. So I'll go ahead and do that. And then I'll go back to our query for the inventory items of the user. And let's see what happens with the description of this item. So I'll hit send. And as you can see, the description is already updated. And this is because as soon as we updated the item in catalog microservice, a message was published into RabbitMQ, and then our inventory service grabbed that update into its local database and is ready to present the updated description as we query for items. So this is great. But now, what would happen if our catalog microservice is having issues? Actually, what happens if it's completely down, right? So it has a major problem. What would happen with an inventory microservice? Can it still keep working just fine? Let's see. I'll go back to catalog. Here's catalog. I'm just going to stop the service. So the service is completely down. And in fact, if we go back to Postman and we try to get items again, let's see what happens. Yep, connection refused because the service is completely down. But then let's try to get all the items on the user's inventory. So I'll hit send. And it still works. Even more, I can try granting yet another item to the user's inventory. So just to test this out, I'm going to start catalog once again. hit F5, back to Postman. Let's go ahead and get the list of items. And now I'm going to grant the antidote to that same user. So let's do antidote into the post operation body. So let's grant the antidote. Let's make sure we use the same user ID. It's right here. The user ID. And then again, like I said, catalog is having problems. I'll just stop it. It's completely down. It's not working. Yet I'm going to go ahead and grant an item to the user. I'll hit send. 200 OK, so it looks like it was successful. And then let's get all the items in inventory now. So I'll hit send again over here. And as you can see, we can query for all the items, and all the items are showing name and description, regardless of the fact that the catalog microservice is completely down. So this is the power of asynchronous communication, and this is how you enable very resilient communication between microservices. Both services are now really autonomous because they don't rely on each other to be available at any given time. One more thing to consider is the case where one of our consumers is not able to consume the message properly, perhaps due to some issue when trying to talk to its local database. So for instance, let's go to our inventory service over here, and I'm going to stop this for now and close terminal. And I'll go here into our consumers, let's say catalog item created consumer, and what would happen if this line here is having trouble, right? So when we go into the consumer, all this logic happens because we are consuming the message. But if we fail, if an exception is thrown in this case, the message is going to be sent into some error queue, and you will not be able to consume it anymore. So at that point, you missed an update from the catalog microservice. So is there a good way to handle this? So it turns to be that, yeah, there's a way to do that. So if you go back to our common library, so here we are back in common library, and I'm going to go to the mass transit extension that we created before and scroll down a bit. And what we can do is to enable, and I'll close this, we can do is enable message retries for the consumption of the messages. So you can go here and say configurator that use message retry, and then here we're going to define our retry configurator. Okay, let's open this section. And then you can say retry configurator that interval. And then the first parameter you're going to specify is how many times you want to retry. So anytime the consumer is not able to consume the message, how many times you want to retry that consumption. So let's say we want to say 3. And then you have to define the time span or a time between retries. Let's say that's going to be time span. Let's import missing namespace from seconds, and that's going to be 5 seconds. Let's also import another missing namespace. We need to use using green pipes here, and that's all it is. So with that logic, anytime a message is not able to be consumed by the consumer, it will be retried 3 times, and with a 5 seconds delay in there. And there's a bunch of different ways to configure this depending on how you want to do your retries. And with that, let's just save extensions. And then if you wanted to consume this in your microservices, as usual, you will go ahead and generate another version of the NuGet package. So in this case, it would be, you would just do .NET Pack. It would be package version, let's say in this case would be 102. And then we send it to the same location as before. Packages, package generated, and then you would just go back to catalog and update its version over here to play.common 102, save, restore dependencies, and then we would go back to inventory and do the same thing, 102, save. And then we'll not exercise this really in this lesson and restore, but that's how you do it. So from here on, both microservices have this capability to retry the consumption of the messages. So that marks the end of this lesson and of this model. You now have two independent and resilient microservices that can collaborate asynchronously to manage a catalog of items and to grant and query for items in a user's inventory bag. You also have a reusable common library that any of your future microservices can take advantage of and that you can keep improving according to your needs. And along the way, you have learned how to use multiple microservices patterns and techniques, the .NET Platform, VS Code, Docker, MongoDB, NuGet, RabbitMQ, and Mass Transit to quickly and reliably stand up new microservices to further expand the capabilities of your system. I hope you have enjoyed the ride. In this model, you will connect the provided front-end project to your microservices to enable basic end-to-end scenarios from a modern single-page application. By the end of this model, you will have a solid understanding of the following: how to get and build the front-end project in your box, how to host the front-end project in a Node.js server, what is the structure of the React-based front-end, what is CORS and how to configure it in your microservices, and how to debug the communication between the front-end and your microservices. In terms of our overall system design, this model is all about the front-end single-page application. You will see in detail how the front-end interacts with all the REST APIs provided by the catalog and inventory microservices. Also, at this point, the front-end will talk directly to the microservices, which is not ideal, but we will do it this way for now, just so that you can focus on the front-end to microservices communication aspects, without the complexity of the introduction of an API gateway. Let's get started. In this lesson, you will install Node.js, which is a JavaScript runtime that will host the front-end portal, and that also includes NPM, the package manager that provides all the dependencies required by the portal. The only additional tool required to build and launch the front-end portal is Node.js, which you can get in the nodejs.org website. Let's see how to install Node.js and verify the installation afterwards. Before installing Node.js, just keep in mind that the pages that you will see next will likely look a bit different depending on your operating system and the versions available at the time that you're taking this course. But regardless, the overall download and installation process should be mostly the same. So let's now browse to the Node.js website. And here, the first thing that you're going to see is right away a few download buttons for your current operating system version and architecture. In my case, that will be for Windows 10 x64. These are the two versions. The one on the left is the most stable version available, and the one on the right is the latest version available, which may not be the most stable one, but it has the latest features. I would recommend going for the most stable version, the LTS version, since that's a recommended one for most users. Now, if the version that you would like to download is not here, you can always go to the other downloads link over here. And here you can pick the right version for your operating system. And you also have a few other download options. Now, in my case, I'm going to go back to the first page, and I'm going to download 14.17.0 LTS. So I'll just click there. And now I'll go ahead and start the installer. So I'll click here. Here's the installer. So I'll just click next, accept, next, next, and next. And at least for this course, I have not seen the need to install any additional tools here. So I'll just click next and install to get installation started. Say yes. And so with that, Node.js is installed in the box. So I'll click finish. And what we want to do now is to verify that the installation has completed properly. So what I'll do is I'll just close the browser now, and I'll open my Visual Studio Code instance here. And here in Visual Studio Code, what I'll do is I'll open my terminal by pressing Ctrl-J. And I'll just type a couple of commands to verify that the tools are installed properly. So I'll just type node-v to get the version of Node.js, which you can see right there, 14.17.0. And now also verify the version of NPM, which is the package manager that comes with Node.js. So I'll do npm-v. and I can see the version right there also. So with this, we know that Node.js has been properly installed and we're ready to move on. In the next lesson, you will learn how to get all the included source code for the front-end portal. In this lesson, you will explore the structure of the front-end code base, how to install its dependencies, and how to build and run the portal. Before exploring the front-end code base, let me give you a few details about it. The front-end is a simple, single-page application that demonstrates one way to interact with all the Play Economy microservices. A single-page application is a web application that dynamically rewrites the current web page with new data from a server, instead of constantly loading new pages. It is built using React, which is a JavaScript library for building interactive user interfaces. I chose React because at the time of creating the course, it was one of the most popular front-end frameworks and is easy to learn, assuming that you have worked with JavaScript before. It uses Create React App to simplify how you do local development, how you build and debug the code in your box, and how you package everything in preparation for deployment. Finally, it is hosted in a Node.js server, a very popular runtime for JavaScript applications. There are a few things that I'd like you to keep in mind as you work with the provided front-end portal in this and the next lessons. This is not a course about front-end development, and certainly not about React. As a back-end developer myself, I only know enough React to build this simple portal. However, I'm probably making lots of beginner mistakes, and I'm probably not following client-side best practices in many places. So please don't use this code as a template for the production level application, but more as a basic example of one way you could interact with the microservices from a modern client. You won't be coding this front end in this course. There is both not enough time, and I'm not qualified to teach you how to build a front end step by step. Instead, I'm providing you the finished portal so you can use it as is. It should work with no issues and no changes required, provided that you make a small update to the microservices, as I'll explain in the next lesson. In this lesson, I'll give you a quick overview of the structure of the front-end code base, with a focus on the areas that interact with your microservices, as opposed to the many components that handle layout, rendering, and many other things. Finally, please check out the links below if you would like to know more about the tech used in the front-end project. So here I am in a new Visual Studio Code instance, and I have already opened my terminal into the projects directory where I have all my files. And as you can see, I have already downloaded and extracted the front-end project files into this directory, play.frontend. And what I'm going to do now is just switch to that directory. And now I'm going to open this instance of code into that directory by doing code.in-r to reuse the window, enter. And here you can see the structure of the project files on the left side. And what I'm going to do is first close this terminal for a moment. I'd like to point you to the readme.md file. So this is a file that will give you a description of what this project is about and a few other things. And in fact, what you can do is just open this preview window with this button that opens a preview on the right side. I'll close the original one. So this gives you a nice view of the readme file. So as you can see, this describes the project, it describes the prerequisites of the project, and then it tells you how to build the project, how to run it locally, and also it provides a bunch of other scripts that are also available. Now, what we're going to do is to actually follow these couple of first lines in this file to get started with the front end. So as it says, what you can do to install all the dependencies of this front end is run just npm install. So I'll open my terminal once again. Right here, scroll down a bit. And what you want to type just at the root of this project is npm install. Hit enter. What this is going to do is to bring in a bunch of node models that represent all the dependencies that this portal depends on, including React, Bootstrap, and a bunch of other things. This is going to take a while depending on your internet speed because there's a lot of stuff that needs to get downloaded. So just give it a moment. Okay, so the dependencies have been installed, and as you can see, there's now a Node Modules folder on the left side. If you expand it, you're going to find a bunch of directories have been created. Right? So now that we have that, we are ready to run the portal. So to do that, if you scroll down in the README, you can see that you can just do npm start, and that's what I'm going to do here. Npm start, enter. So this is going to compile the entire code base, and then it's going to start the Node.js host. Okay, so it compiles successfully, and as you can see, we get an address here to browse locally to it. So I'm going to copy this address, localhost 3000, and I'm going to go to my browser. I'm going to paste that there and hit enter. And there it is. The portal is up and running in this box. Now in the home page here, what we have is just a few basic things like the description of the project, and then a couple of links, both to go to the catalog section to get the list of the catalog items, and the inventory section so that you can inspect which are the items that are in the inventory bag of a user. Notice that we also have a navigation bar at the top that takes you either to the home or to the catalog and inventory sections. There's also links here to go to the RabbitMQ portal if you wanted to explore what's going on with the queues. And there's also links here to explore the Swagger UI OpenAPI documentation for both catalog and inventory service. And also a few other things, general links to the different technologies that were used to create the whole system. Now, before we go and dive into the catalog and inventory sections, which are, of course, the most important parts of this portal at this point, let's go back to Visual Studio Code for a moment. And let's explore briefly the files that are available here, just so that you get an idea of how this project is structured. So what I'm going to do is just close this terminal for now and close the README. And the first file that I'm going to show you is package.json. This one here describes all dependencies of this project, which are all the node modules that are installed by now. And like I said, these include things like React, being used for all the components, interactive and dynamic components used across the portal, Bootstrap for layout, and a bunch of things for being able to do routes in the client side, the React scripts, which are the ones that we can use to start the portal, and a few other things. And yeah, many other dependencies. Now let me close this and then take a look at the public folder here. This one is the one that defines index.html, which is what we call the page template. So in a single page application, like I think I mentioned before, there's not really a navigation into different pages of a portal. There's no reload of pages. There's just one page, in this case index.html, where all of these dynamic components are loaded and refreshed constantly. And in fact, in this section here, in this div, root, here is where all the JavaScript files or JavaScript content is injected with all the React components. Now this file also references config.js, which happens to be over here. And this is a file where if you're asking where is the addresses of all the microservices, this is the file. So this is where you're going to see the address of the catalog microservice and the address of the inventory microservice right there, as well as the address of the RabbitMQ portal and a few other derived addresses for the items APIs in catalog and inventory. Now the most important directory actually here is the source directory, because this is the one that contains all the React components. So this is pretty much is the heart of the project. This is where the system logic happens. And in this file, if you go to index.js, this is the root where we start rendering React components, and we are asking it to start rendering them in the root div that we just saw in the HTML. This one here, we saw that there's a root div, and that root div is where index.js will get rendered, as you can see right here. And so the first React component that we actually start rendering is this app component over here, which is coming from app.js. This app component defines our app by using first the layout component, which is in charge of rendering the basic layout of the system. As you can see over here, if you expand components, layout.js, this is one that defines the navigation menu at the top, the container for all the other components in the middle, and then the footer at the bottom. Back to app.js. As you can see, we have layout, and layout defines that inside of layout, we're going to have a component for the home, a component for the catalog, and a component for inventory. So then if we just go into the components directory, we have our catalog file. And this is the one where you can start really seeing interesting things, because this file allows you to communicate to the catalog microservice. So go down into the populate items method over here. You can see that here is where we are actually talking to the catalog microservice, and then we're getting a response from it, and that's the one that we are collecting and setting it into the client-side state that later on, if you see at the bottom, is being rendered as a list, as a table into the page. Okay, and it's the same idea with the inventory.js, which is able to render the items in the inventory bag of a user. We also have a few model files and form files, like item model, which is the one that is used to render the model dialog. So you can go ahead and either create or update an item, and the item form, which is the one that actually shows the form inside that model. And the same way, we have a model for granting items for a user so that it can go into his inventory bag. So a model and a form for that same purpose. And lastly, we have the .vs Code folder, which you should be very familiar with at this point, where we also have a launch.json file, where we define different configurations that you can use to start debugging either the server side or the client side of this portal. So you can see we have a configuration for the server. We have named it server. This is going to be the one that can launch the NPM server or the Node.js server, and one configuration for launching the client at the location of the client in the browser. There's also a compound configuration, which I named server client, that can be used to launch both the server and the client at the same time in your local box. Okay, so I'll just close this. So now let's go ahead and try that catalog section. So I'm going to open the terminal once again here. So our front end is still running, but what we may not be running right now is the catalog service. So let me go back to catalog. Here's my catalog code base. So I'll just switch to src, play that catalog service, and then I'll do .NET run. So catalog is now up and running. So let's go back to the portal, the browser. And in order to see the list of catalog items, what you can do is either click in catalog in the navigation bar over there, or you can click in this catalog link right here. And I'll click on it. And this should display the list of catalog items, but as you can see, that is not working right now. So we cannot load the items. So there's some problem happening here. And so on the client side, one way that you can tell what's going on is by using the browser developer tools, which usually you can go to by pressing the F12 key, which I'm going to do now, F12. And this opens the developer tools section. Now on this one, there's a bunch of tabs, but the one that you're interested in is in the console tab. So click on console, and this is going to show you what's going on. So as you can see, there's an error, access to fetch at HTTPS localhost 5001 items, which is the address of the catalog microservice, from the origin HTTP localhost 3000, which is the address of this of the front end, has been blocked by CORS, the CORS policy. So no access control allowed origin header is present in request resource. So what is this CORS thing about? That is going to be actually the focus of the next lesson. So in the next lesson, we will learn about cross-origin resource sharing, also named as CORS, and how it can help us enable the communication between the front end and our microservices. In this lesson, you will learn about cross-origin resource sharing, also known as CORS, what problem it solves, and how it can help us enable the communication between our front-end portal and our microservices. To understand CORS, let's first understand what a cross-origin request is. Let's put our catalog microservice to the side for a moment, and let's imagine that the Node.js web server that is hosting our front end is also the server that hosts the REST APIs to interact with the Mongo database that owns the catalog data. In this scenario, the browser initially navigates to the web server URL to load the front-end homepage. And then, when the catalog section is requested, the browser makes a GET request to the catalog REST API to the same web server URL, to which the server will reply with a JSON representation of the catalog data. The address from which the browser calls the REST API is known as the origin, and is made of the combination of protocol, host, and port, which in this case is HTTP localhost 3000. Notice how the origin in the browser matches exactly the origin of the server that provides the REST API. Let's now go back to our actual scenario, where our catalog microservice hosted in ASP.NET Core's Kestrel web server is the one providing the REST API. Now, when the catalog section is requested in the browser makes a GET request to the REST API at the origin of the catalog microservice, which is HTTPS localhost 5001. Since both the protocol and port of the catalog microservice are different than the one in the browser, this is known as a cross-origin request. The microservice will return the catalog data just as before. But by now, the browser knows that this response comes from a different origin, since it had set the origin header in the request. Therefore, it rejects the response data with a CORS error. This happens because browsers follow what is known as the same origin policy, which states that a web application can only request resources from the same origin the application was loaded from. Browsers enforce this to prevent malicious websites from reading confidential information from other websites. Unfortunately, this is also preventing our front end from reaching the catalog microservice. So how can we fix this? Here's where CORS comes into place. CORS allows a server to indicate any other origins than its own from which a browser should permit loading of resources. Here's how it works. Once again, the browser has loaded the front-end page. Now, the catalog section is requested and a GET request is sent to the catalog microservice. And since catalog is hosted in a different origin, the browser appends the origin header. The difference this time is that the catalog microservice has been configured with the access control allow origin header, which indicates all the other origins that are allowed to call the REST API. In this case, this header has been configured with the origin where the front end is hosted, HTTP localhost 3000. Once catalog sends the items data back to the browser, it appends this header to the response. The browser now compares the value in the origin header it sent to the value in the received access control allow origin header. Since they match, the browser now allows the response data to reach the front end. This works for simple requests like GETs, but for POST, PUT, and other methods, things work a bit differently. When a cross-origin request may perform some sort of write operation on the resources owned by the server, like is the case when performing a POST, PUT, or delete request, the request needs to be first pre-flighted. This means that an additional initial request needs to be sent to the server to determine if the actual request is safe to send. Going back to our scenario, imagine we now want to create a new item in the catalog, and therefore our front end will send a POST request to the REST API. However, since this is a post of JSON data across origins, the browser automatically sends first a request with the options method. This time not just adding the origin header, but also two other headers called access control request headers and access control request method. Access control request method indicates that when the actual request is sent, it will be a post. And access control request headers tells the server that the request will come with a content type header, in this case. The server should have been configured to respond with corresponding headers to indicate what it allows. The headers returned by the server are access control allow origin, access control allow headers, and access control allow methods. If the values returned in these headers match the values in the headers sent in the request, the browser accepts the post request and submits this original request to the server with the JSON payload of the new item to create. The catalog microservice creates the item and returns the expected 201 status code. As you can see, the key to a successful cross-origin request is in the appropriate course configuration on the microservice that exposes the REST API, since only the microservice can declare the allowed origins. But how do we properly configure CORS in ASP.NET Core? That's the focus of the next lesson, where we will add the missing CORS configuration to both the catalog and inventory microservices. Let's now fix the CORS-related errors we are getting in the browser by configuring the CORS middleware in the request pipeline of our microservices. And let's start with the catalog microservice. So I have the catalog code base open here in Visual Studio Code. And what I'm going to do is open app-settings.development.json first. Here I'm going to declare the origin of the front end so that we can properly configure it in startup later. I'm using app-settings.development.json and not app-settings.json because the origin of the front end is just a development server at this point, and we will not need a CORS policy for that origin in production. So what I'll do is I'll just open another section here. This is just going to say allowed origin, and that's going to be the address of our front end. So this is HTTP localhost 3000. Now that we have that, let's go into our startup file. And here's where I'm going to collapse the Explorer for a moment. Let's scroll down a bit. And what I'm going to do is define first a constant to represent the name of that setting that we just created. So this is going to be private const string allowed origin setting is going to be the name that we just created over here. I'm going to copy it, allowed origin, right there. And now that we have that, we can actually configure CORS. So to configure CORS, what you want to do is go down into the configure method, which is where you configure the request processing pipeline. And so, like I said, this is mostly for development scenario at this point, because the front end is a development web server. So what I'm going to do is take advantage of this m.isDevelopment section, which only happens for development scenarios. And I'm going to add another piece over here. So I'm going to say app.useCORS. And here we're going to provide the function that configures the CORS configuration. So I'll do builder, and I'll do this. And then we're going to say builder dot with origins. And here's where we're going to specify that origin, which at this point comes from the configuration data. So it's going to be configuration. And here we're going to pick the right key from the configuration, which in this case is allowed origin setting. So remember that this configuration is the configuration object that has been declared here, right here, configuration object, which is populated automatically by the ASP.NET Core runtime. So that configuration object contains all the data at this point of app-settings.json and app-settings.development.json, including the allowed origin setting. So you can use this to just go ahead and get the key that corresponds to the allowed origin setting that we just declared. So configuration, and then allowed origin setting. So that allows the origin, but we also have to tell it which headers and which methods are allowed from the client side. So to do that, what I'm going to do is just say dot allow any header to allow any of the headers that the client wants to send. And we will say allow any method to allow any of the methods used from the client side, including get, post, put, and all these other verbs. Okay, so with that, we have allowed the front-end origin, and we have said any header and any method should be allowed. Okay, so with that, we should be able to properly invoke the methods in the microservice from the client side. So let me open up my terminal once again, and I'll do .NET run. And then I'll go back to the browser where, as you remember last time, we did have this course error. So now I'll just refresh the page. And as you can see, things are loading properly. And in fact, if we inspect briefly the network section here, and we inspect the items request that we made right here, you can see that the browser did send the origin header in the request for localhost 3000, and the catalog microservice responded with the access control allow origin header over there, which is why the browser allowed the response. So that's how you configure CORS. And since we did this for the catalog microservice, we should do the same thing for the inventory microservice. So let me go back now to our inventory code base, which I have opened here in this other Visual Studio Code instance. And I'm going to do just pretty much the same thing that we just did. So here, and in fact, I'm going to copy a few sections here. So from catalog, I'm going to close the terminal for a moment. I'm just going to copy this allow origin section into inventory, allowed origin. Then back to catalog, I'm going to copy the allowed origin setting from startup. Back into inventory, in startup, at the top, I'm going to place that constant. And then finally, back to catalog, into the configure section, I'm going to copy the use CORS section here. And back into inventory, I'll collapse this for a moment. In configure, I'm going to add this right there. Okay, so this enables the same configuration for inventory as the one that we have in catalog. So both microservices are properly configured now. So in the next lesson, we will explore in more detail all the scenarios enabled in the front end and how its React components are interacting with the microservices.